Alright, welcome back. Let's do example 4. A ball is projected vertically upwards at a velocity of 16 meters per second from the ground. Ignore the effects of air resistance. Use the ground as a zero reference. Calculate the time taken by the ball to return to the ground. Right, so it means we're looking at this trajectory where the ball will start, and the ball goes up, then turns, and then goes down. Sometimes it's advisable to have these diagrams. So the initial velocity, if upwards, is positive. So the initial velocity is 16 meters per second. And then what will be the final velocity here? Remember, we discussed this. We say that when the object returns to the starting point, the magnitude of velocity is the same as the initial velocity but different in direction. So it's going to be negative 16 meters per second, right? But if you take downwards as positive, then the initial velocity is going to be negative 16 meters per second, and then the final velocity is going to be 16 meters per second. Please take note of that. So we're going to do these ones when upwards is positive and also when downwards is positive, right? And then when upwards is positive, acceleration is negative 9.8 meters per square seconds. And then if downwards is positive, then acceleration is 9.8 meters per second. Right, so we have final velocity, we have initial velocity and acceleration. So which equation of motion can we use there? We can use the equation Vf is equal to Vi plus A delta t. We're looking for time. We have the initial velocity, we have the final velocity, we have the acceleration, so we can find time. We have listed our information here. There's no need to relist it. Right, this is upwards as positive. This is downwards as positive. And upwards is positive. So it's going to be negative 16 is equal to 16, then plus our negative 9.8, and then delta t, right? And then this is negative 32. After transposing this is equal to negative 9.8 delta t. So divide by 9.8 on both sides of the equation. Our t is equal to 3.2653, goes on like that. So our time will be 3.27 seconds. When downwards is positive, we still use the same formula. F is equal to initial velocity plus A delta t. So now the final velocity now is positive 16 is equal to initial velocity is negative 16 plus A, which is 9.8 positive, then delta t, right? Transpose, then 32 is equal to 9.8 delta t. Divide by 9.8 on both sides. So time is equal to the same. We're going to get the same answer, 3.27. Okay, after rounding off this one. That is A. Right, let's do B. Right, we're going to start by taking upwards as positive, and then after that we're going to take downwards as positive. 1 second after ball A is projected upwards, a second ball B is thrown vertically downwards at a velocity of 9 meters per second from the balcony 30 meters above the ground. Right, refer to the diagram alongside. Calculate how high above the ground ball A will be at the instant the two balls pass each other. So when these two balls are passing each other, it means they are at the same height above the ground. Please take note, there's a difference between displacement and the height above the ground. When they pass each other here, they'll be same height above the ground. Let's say YA is height above the ground for ball A. Then YB is height above the ground for ball B. We're taking upwards as positive. Now let's look at what we have. Right, let's start with ball A. What will be the initial velocity? Upwards is positive. So the initial velocity is positive 16. Right, so VI is 16 meters per second. And then what else do we have? Acceleration. What is it going to be? When you take upwards as positive, it's always negative. Negative 9.8 meters per square second. Right, and then what would be the displacement when they meet? Right, for A, the height above the ground and the displacement are going to be what? Just the same, isn't it? It means we can say that delta y for A is just equal to the height above the ground for A. Okay, right. Let's say when they're meeting here, this will be the displacement of A and also the height of A above the ground. Then we're taking upwards as positive, so it means the displacement must be positive. Let's do the equation for A. So which one are we going to use? We have the initial velocity, we have acceleration, and then we also need an equation of motion with the displacement and time. And then this is the one that we're going to use. Ya is equal to Vi delta t plus half at squared. Then let's substitute what we have. Okay, we say delta y. This is just delta y. Let me just put delta y here. Displacement is just equal to the height of A. So Ya is equal to the initial velocity 16 delta t plus half. And then acceleration is negative 9.8. Then delta t squared. Right, let's simplify this. Height of A above the ground 16 delta t minus 4.9 coming from these two, then delta t squared. That's equation 1. Then let's deal with ball B. We have to be careful here. We said upwards is positive. Now, what will be the displacement of ball B by the time it meets ball A? It would have moved this distance, right? So what will be the displacement here? This displacement will be 30 minus YB. Okay, this displacement will be 30 minus YB. That will be the displacement of what? Of B. But now we're taking upwards as positive. So it's going to be negative 30 minus YB. Okay, so for ball B, delta Y is equal to negative 30 minus YB, right? And then the initial velocity, that this one is going down. So it means Vi will be negative 9 meters per second. Right, for A, we're taking upwards as positive. So A is equal to negative 9.8 meters per square second. So okay, let's create an equation for ball B. So displacement is equal to Vi delta t plus half at squared. Let's substitute. And then we have to be careful with B when it comes to time. It says 1 second after ball A is projected upwards, a second ball B is thrown vertically downwards at a velocity of 9 meters per second. What will be the time for ball B? So it means the time for ball B will be delta t minus 1. Please be careful. It will be delta t minus 1. We discussed this in the previous example, in example 3. Okay, right. So it's delta t minus 1. I gave an example and said, if let's say it takes me 10 seconds to move from point A to point B, right? If you start 2 seconds after me, and then we meet at this point at the same time, we meet at point B, how long did it take you to move from A to B? It will be 8 seconds. Because it started 2 seconds later, so it's going to be 10 minus 2. So this one here, 1 second later, so it means it's going to be delta t minus 1. Or delta t is for what? Is for ball A. That is the time for ball A. Then ball B now is going to be change in time minus 1. We say displacement is going to be negative. So it's negative 30 minus YB, right? Upwards is positive. So this is displacement below is starting point, so it's going to be negative. So it's negative, and then initial velocity negative 9, then time will be delta t minus 1, then plus half, and then we have negative 9.8, and then delta t minus 1 squared. Okay, right, let's remove this bracket. Negative 30 plus height of p, and then we have negative 9 delta t plus 9. Okay, right, and then this is like negative 4,9. Let me just write it first. Negative 4,9. Then let's expand this. You can expand this in the normal way. Delta t minus 1 times delta t minus 1. Expand this using FOIL. You must get delta t squared minus 2 delta t plus 1. You must get that, right? So, and then I'll transpose negative 30 to the right hand side. So it's equal to negative 9 delta t plus 9. And then let's remove the brackets here. Negative 4,9 delta t squared. Then negative 4,9 times negative 2, that is positive 9,8 delta t. And then negative 4,9. Okay, and then plus 30. Remember, we transpose this. Plus 30. Let's simplify this. Right, yp is equal to, we have this, so it's negative 4,9 delta t squared. Then these are like terms, and then these negative 9 delta t plus 9,8 delta t, that will give us plus 0,8 delta t, right? And then we have this 9, we have this negative 4,9, we have 30, right? This must give us 34,1, right? So this is equation 2. So we have equation 1, we have equation 2. Remember, we say this is the height of ball B above the ground. This is the height of ball A above the ground. So when they meet, YA is equal to YB. It means their heights above the ground are the same. So we just equate this to this. Okay, so it becomes 16 delta t minus 4,9 delta t squared is equal to negative 4,9 delta t squared plus 0,8 delta t plus 34,1. Okay, this and this will go. If you transpose, they will subtract each other out. Then what are we left with? 16 delta t minus 0,8 delta t, that is 15,2 delta t, right, is equal to 34,1, right? And then divide by 15,2 on both sides. Delta t is equal to 2,243,421,053. So delta t is equal to 2,24 seconds. But they said, calculate how high above the ground ball A will be at the instant the two balls pass each other. So want the height of ball A, which is this. So we substitute our time there. So it means YA is equal to 16, then 2,24, then minus 4,9, 2,24 squared. Then put this in the calculator. YA is equal to 11,25376, which is the height of ball A, 11,25 meters. Alright, let's take downwards as positive. So we're saying that for ball A, so now it means the initial velocity is going to be negative. So VI is equal to negative 16 meters per second. And then A is going to be positive. If downwards is positive, A is always positive. Okay, meters per second squared. Alright, we have to be careful with displacement of A. We're taking downwards as positive. So what will be the displacement of A? It's going to be negative because we're taking downwards as positive. So it means now displacement is going to be negative YA. Okay, so we're using the formula delta Y is equal to VI delta T plus half AT squared. Okay, so our displacement is negative YA is equal to the initial velocity is negative 16 then plus half, then a is negative, a is positive because downwards is positive, so a is always positive if downwards is positive, like this, and then delta t squared. So we have to be careful with our displacements, velocities, and acceleration, right? And then let's make y the subject. Let's make this the subject. Divide everything by -1. This one is also positive 4,9. Okay, so it becomes ya is equal to 16. This is 16 delta t here. What did I do here? Okay, 16 delta t, and then because we're dividing by -1, this becomes minus 4,9. 4,9 coming from half times 9,8. Then delta t squared, which is equation 1. Right, let's work with ball B. Right, we have to be careful here with our displacement. Remember, we said that this is 30 minus yb. Okay, the point where they're going to meet, right, the height above the ground is going to be 30 minus yb. And then what will be the displacement of ball B? If we take downwards as positive, so we take this as it is, it's positive. So delta y is equal to 30 minus yb, right? Then acceleration, if downwards is positive, that is 9,8 meters per second. Initial velocity here is downwards, so it means also positive. Vi is equal to 9 meters per second. Right, what else do we need? Or let's substitute what we have. So delta y is equal to Vi delta t plus half a delta t squared. Let's substitute what we have. So it's 30 minus yb is equal to, then initial velocity is 9, so it's 9 delta t. We have to be careful with the time for b. Remember, say that for b, the time is delta t minus 1. So this should be delta t minus 1, and then plus half, then our a downwards, so this is 9,8, then delta t minus 1. We discussed this when we were looking at upwards as positive. All right, and then you can expand this normal way, right? You get that this is 30 minus yb is equal to 9 delta t minus 9, then plus 4,9, right? And then this is delta t squared minus 2 delta t plus 1. Okay, right. And then let's expand this. And then we're going to transpose positive 30 to the right, becomes negative 30. It's going to be negative yb is equal to 9 delta t minus 9. Then we're distributing 4,9 here, so it's going to be 4,9 delta t squared, and then minus 9,8 delta t, then plus 4,9. And then remember we transpose 30, so it's minus 30, right? Then we can simplify this. These are like terms, so this gives us negative 0,8 delta t. Then we have 4,9, so this is 4,9 delta t squared, and then this and this and this will give us negative 34,1. Right, we can then divide everything by -1, so yb is equal to, let me start with this, negative 4,9 delta t squared, then plus dividing everything by -1 plus 0,8 delta t, then plus 34,1. So that is yb. And then we're saying that this is equation 2. So we're saying that at the point where they are going to pass each other or meet, ya is equal to yb. Okay, so you can say ya is equal to yb. So meaning that 16 delta t minus 4,9 delta t squared is equal to negative 4,9 delta t squared, then plus 0,8 delta t plus 34,1, right? If you transpose, this becomes positive 4,9 delta t squared, so they cancel each other out. And then we remain with 16 delta t minus 0,8 delta t, we get what? 15,2 delta t is equal to 34,1. Then we divide by 15,2 on both sides. Delta t is equal to 2,24. We got this in the previous calculation. And then what do we do with this? We need to find the height of ball A above the ground. So we're using this equation. Where there's t, we put 2,24. So ya is equal to 16, 2,24, then minus 4,9, 2,24 squared. Then get your ya is equal to 11,25 meters.